somewhat weird.
Got here. Oh, everybody. Oh, wait a minute. That's okay. So we're just going to wait until they come in. Okay, there's Skia.
Okay.
How long was your talk?
About an hour.
Good.
Yeah.
We got time.
Plenty of time. No worries.
See, their meeting is in person. Why do they even have this problem?
Yeah. Yeah, I thought it was automatically connected to the room, but I guess maybe not.
It's actually the other way around. The room is connected to the meeting.
I see. Okay. This room was assigned.
And that makes it confusing.
Yeah. Like true computer people, they ignored the physical world. The root of truth is in the cloud.
The cloud meeting is the real thing.
The way the physical world. So there's a missing layer of abstraction.
That's right. That's a Skia.
Yeah, the cloud meeting is the one real truth. The room is all in your head.
Yep, exactly.
Hey, how's it going? Oh, thank you. Thanks.
We're having fun with meeting rooms. We're working through it.
Oh, okay.
Meeting started. Okay.
Anybody join?
We got Linda and yeah, we had Bob got, oh, there's another one. Okay. Not the one I noted before,
It
so.
looks like there was a in the NWCPP meeting. I put the link, so hopefully there'll be.
Ah, perfect. Okay, we'll give them a little bit. Didn't.
Yeah, nobody left in the NWCPP.
Okay.
All right. Got it.
Yep, I know Bob Goddard was on there, so we'll give him a minute.
I think it might still make sense to connect a GPU to your Apple laptop if you're doing AI work. Just
Oh,
not
yeah.
for games.
Yeah.
Right.
Oh, yeah.
Yep, and that's actually what the case we were using at when I actually was working with a group that did that. It was they were training an AI model basically.
Mhm.
And yeah, I
Put
think
all the data on there and let
I
it
think
turn.
that's what they did. Yeah, it was actually video, so they may not have been able to put all the data on there at once.
Sure.
But it's put the data there, run a
Put some more.
run a set, put another. Yeah,
Enough, like the cable's not your bandwidth, you're not your bottleneck.
no, it actually turns out the Thunderbolt cables are amazingly
They're
fast,
quite
even
fast.
compared to a PCI. You don't have as many lanes, but
Yeah, I mean, you get
they still scream.
a good fraction of the speed still.
Mm-hmm.
Are the people going to get kicked out at 7:30? Because that's when the meeting is, or?
No, we should be able to go.
Okay.
Yeah, that would be another problem.
We got shuffled.
Well,
It'd be okay.
partially. They shuffled the physical rooms, but didn't shuffle the virtual meeting. So we're pulling everybody else into this virtual meeting.
But
Hopefully it doesn't kill us.
This is about music. So.
Yeah. Nice.
Well, we've got two,
Musical as my last.
so I'm gonna go ahead and,
It won't be as musical as my last one.
Oh.
Get a chorus going.
Okay, in addition to having meeting room problems tonight, we were having a little fun with my laptop. Okay, welcome folks to the Northwest C++ Users Group. I'd like to thank Microsoft for sponsoring our reactor room and our team support. And we do have a code of conduct being on Microsoft campus. So be nice to everybody. Announcements, I am still looking for presenters for 2025. Pretty good so far. I've got February open in the first part of the year. So if anybody would like to take February, that's still there. I do have a backup just in case. Actually got a couple backups just in case. Just a reminder, no meeting in December. Happy holidays, everyone. After the main meeting, there's a group of people who have started meeting at the Red Robin on 148th and 24th in their coffee club. Everyone is welcome to join. You do not have to attend this meeting to join, but you have to attend this meeting to find out about it.
Oh, you can find out through your email.
You could, that's true. And basically at this point, I'll turn it over for our feature presentation. Keep your questions short and focused, and don't interrupt the speaker. All right.
Cool. Everyone can see that here and online, hopefully. Awesome. Cool. Well, hi, everyone. I'm Jatin. Today I'll be talking a little bit about the Jive programming language. I think I've met most of you, but for anyone who hasn't met me, I'm a freelance audio signal processing developer here in Seattle. And before I was here, I worked for a little bit at Tesla Motors. And before that, I was studying at CCRMA, which is like a technology program based at Stanford. And most of what I do as kind of my day-to-day job is making software for musicians and music producers. So maybe that's software that's being part of a synthesizer, part of a post-production effect, like a compressor or distortion effect that a mixing or mastering engineer is going to use. Or maybe it's more of a live performance effect, like a guitar pedal or something that people would use on stage as part of their performance. So a few things I'll talk about.
That's it.
Nice.
That's I was trying not to interrupt you, but I was trying to get the camera turned over to you instead
Looks
of.
like a new camera. I don't know if they have a different system. I don't know.
You might have to ask
It's like there's 3 cameras.
It's splitting it in software.
Oh, yeah, I see what it's doing. Okay, and it does have one on you. I just couldn't see it. Okay, sorry for the interruption. Continue on.
No worries, no worries. Yeah, so I'll just start by giving a brief introduction to the Jive programming language, and then talk about a few features that I personally find interesting. One is the way that the language approaches compile time programming and this thing called the context, which I'll explain a bit further. And then I'll talk a bit about how I've used Jive for audio programming, and specifically how it approaches things like memory allocation and what they call a compile time sanitizer, which hopefully will be interesting to everyone. So a few quick disclaimers. I'm not affiliated with Jive. No one's paying me to be here. I've never contributed to the language other than just as a beta tester. I wouldn't consider myself an expert in the language. I've been programming in C++ for about 10 years now, and I'm definitely not an expert in C++, and I've been coding in Jive for significantly less time than that. So yeah, I wouldn't consider myself an expert in any of these things. And I'm not here to try to convert anyone to use Jive. I'm just trying to share some features of the language that I think are interesting and hopefully are interesting to you all as well. And if you've used the language before, or if you gain access to the compiler in the future, certain things may work differently, but everything I'm talking about is specifically related to this version of the compiler. So mileage may vary if you're using any other version. I also wanted to split up some of the statements I'm going to make here. So anything in white is a verifiable fact for yourself if you want. Anything in yellow is my opinion. Probably not something you can verify, but I believe it. And then anything in orange is something that the Jive developers have claimed, but is not verifiable. So for example, there are some features that they have said, oh, this will be part of the language in the future. but of course, things may change in the future. No one knows. So I just wanted to clarify who has said what and what can be verified and what can't. All right. So Jai, oh man. Okay, these are supposed to be YouTube thumbnails, but that's okay. So Jai is developed by this fellow named Jonathan Blow, who is a game developer. I don't really play video games. So I haven't heard of these games, but apparently these are, or I haven't played these games, but apparently these are games that he has worked on. And when the language was introduced, it was introduced as a programming language for games and presumably for game developers. There was a talk on YouTube in 2014, kind of a series of talks where he introduced the ideas for the language. And then there's been a series of demos and question and answer sessions that are also available on YouTube, kind of around 2014 until I think the most recent one was a month or two ago. And there was a talk at the Game Lab conference in 2018, which is also very interesting if you're maybe looking for a more of an overview of the language that goes into all of the features that were available at that time. Currently, the language is in a closed beta program. I think the beta started in January of 2020, but I haven't been able to exactly confirm that. And then I was added to the beta in February of last year. So I've been working with the language on and off for about a year and a half at this point. Now, the developers claim that Jai is a temporary name and that when the language is officially released, there will be an official name that is attached to the language. I think it might be a little hard to change since a lot of people on the internet already know it as Jai, but we'll see what happens. So some basic information about the language. Jai is a compiled language. You can compile it directly to x64 machine code or to an LLVM intermediate representation, and then use LLVM to get it to any sort of thing that LLVM supports, which is a wide range of things. There's a number of platforms the language supports. So I personally have shipped Jai code on Windows, Mac, and iOS. I know some other people who have shipped code for Linux and Android. I know there's some level of support for WebAssembly and for certain gaming consoles, probably for some embedded devices as well, but I'm not as big on everything happening there. The language has a lot of things that might be familiar to people coming from C and C++, so the language is strongly typed, has structs, enums, functions, or procedures, they usually call them. They have what they call hygienic macros, which are a little bit like C macros, but also different. I'm not really going to touch on that too much in this talk. It has pointers, it has what they call polymorphism, but for our purposes, for people used to C++, it's closer to what we think of as templates. I'll explain this in a little bit. There's also some features that are intentionally not part of the language. The language does not have header files. It doesn't have a build system, at least in the way that we as C++ programmers would think of it. No constructors or destructors, no inheritance or virtual functions, although you can make your own kind of vtable thing if you want. There's no RAI, there's no garbage collection. Again, you could probably roll your own of these types of things if you wanted to, but it's not part of the language by default. There's no exceptions. There's no const variables, which I'm still trying to come to terms with, or at least no sort of, in C++, like a runtime constant. There are compile time constants, but runtime constants don't exist. And I'm still trying to come to terms with that. And the developers say that the syntax is not final. So I think the plan is that once the language is feature complete, there's going to be kind of a pass to clean up the syntax and hopefully make it a bit better than it is currently. Personally, I think it's pretty good in its current state, but maybe they have ideas to make it even better. Now, I guess I wanted to talk a little bit about why the language exists, or at least my interpretation of it. So when I'm programming, a lot of times I consider my programming work very creative. And really what this means to me is that there's not really a right answer that I'm trying to achieve. Sometimes there is, but usually there's not. And so usually when I'm programming, I'm constantly asking myself this question of, well, which version of this algorithm or this code, which version sounds better? And so really it's kind of a loop of trying something, seeing how it sounds, trying something else, seeing how it sounds, and continually iterating around this loop until I've converged hopefully to something that I like how it sounds, or hopefully it's the best version, but of course that's up to the listener. And I think in other creative programming mediums, let's say, there's a similar question. So I think for game developers, maybe there's a question of, well, which version is more fun to play? If you're a UX programmer, then maybe which version is easier to use or feels smoother or something like that. I think, again, if you think about more types of creative programming, there's probably different questions that you might have to answer. And when you're programming in this way, I think it's really important to have what the Jai developers call a low friction programming environment. And what they, as best I can tell, what they mean by this is that you get fast compile times. So this is very important for kind of when you're going around this loop again and again and again, the longer you have to wait for your program to compile, the slower your loop iteration is going to be, and the less ideas you'll get to try, and the harder it is to evaluate the before versus after just because of how much time has passed in between. And then kind of a more general version of that is that it should be very cheap to try out new ideas. So if you want to try something, you shouldn't have to, let's say, fill out 5 different types of constructors before you can try out an idea. You should be able to just try it out. And then if you don't like it, you throw it away. If you do like it, maybe you clean it up a little bit, make it nicer, and then move on. Kind of going along with that, when you're working on a creative problem, a lot of times these are very hard problems in the sense that there's a lot of layers to them, and also that they're often problems that have not been solved by other people just because they're so specific to the exact type of thing that you're working on. And so part of the idea for Jai is to be a tool that can solve hard problems, not just kind of trivial, easy problems. Like, it doesn't matter if you can implement quicksort in 1 or 2 lines of code. It matters more if you can solve a problem that's never been solved before in a way that is understandable and hopefully not too time consuming. And then finally, programming should be fun. So when you're doing creative programming, as with any other creative thing, you kind of want to stay in your flow and you want to feel good about what you're doing. And if that breaks down, then it's very hard to be creative and it's very hard to come up with new ideas and to feel good about those ideas. So the more fun programming can be, the better it is for creative programming, at least. So I wanted to touch a bit more on fast compile times. So Jai currently can compile around 250,000 lines of code per second. But I actually, when I was putting these slides together, I discovered I had a pretty nice comparison where I had basically the exact same audio effect implemented in C++ and in Jai. And so I figured I'd do a little race. So I did a clean debug build for both projects. So C++ compilation time with Clang 17 and Ninja took about 3.5 seconds. The Jai compilation time was about 10 times faster. This is using their x64 backend. The LLVM backend is about a second, a little more than a second. But yeah, the x64 backend is really, really fast.
Sure. So I've got a question about that. The thing about C++ is you include these header files like windows.h that include header files, and you're compiling like an extra 100,000 lines of header file in addition to the maybe 200 lines that you wrote.
Sure.
So you said one of the big advantages of Jai is that there's no header files included. So I wonder if most of this difference is just not having to compile the header files.
That's a good question. Yeah, I'm not 100% sure. I would guess that has something to do with it. I would also imagine there's maybe some other things as well, but yeah, that seems like it can't hurt, right? Yeah, that's a good point. I've been told that there's larger speed differences for bigger projects, and at least it feels that way to me when I've worked on bigger projects, but I don't really have any hard numbers. And as you get to bigger projects, it's hard to find good comparison cases. Like that audio effect was a very nice comparison case because it was literally the exact same functionality in both languages. As you get to bigger projects, you're probably not going to find such a exact comparison. But yeah, it is possible to compile some very complicated and large projects in under a second or a little more than a second sometimes. The developers also claim that they're going to do kind of a full optimization pass on the compiler after it's feature complete and all of that. So maybe it could be even faster than it is currently. I think at some point I heard the number 1,000 lines or 1,000,000 lines of code per second thrown around, but I wasn't able to find where I heard that. So I don't know if it's something that's been officially claimed. So here's a quick taste of the language. So this is a compile time constant variable. So you have a name, you have a colon, and then you have the value. Here the type is being implicitly assumed it's an int, But if you wanted to explicitly say the type, you could put that in between the two colons here. And that would be, you could say, oh, I want this to be a float or a double or something like that. Here's a regular variable. So this is not compile time constant. This is a regular variable you can assign to and whatever. And here we are defining the type explicitly. And so here we have the name, we have a colon and an equals instead of colon colon. The colon equals means that it's not compile time constant. And then you have the value. This is a struct. So again, we have the name, colon, colon, and then the type. The value, I guess. And so here we have a member variable and a compile time constant variable. There are no member functions in Jai. I thought that would bother me when I first started using the language, but it hasn't really. I mean, I programmed in C before, and it's actually a bit easier than C in some other ways that I'm not going to get into, but yeah, no member functions. And then this is a function. So again, you have the name, colon, colon, and then everything else. So we have an argument 1, that's an integer. Argument 2 is a pointer to our struct. And then we have multiple return values. So we can return an int and a string. And then we just have some logic to do our return. So does that seem roughly familiar coming from C, C++? Yeah.
Certainly, there's no return type that you have to put with the function.
The return type is this.
Oh, there it is.
Yeah,
Oh, sorry.
Yeah. But yeah, it looks a little different because there's
I didn't see.
two return types in this case. Yeah. And then if you want to compile and run a program, maybe this is a hello world program, you would just run the compiler on that file and it'll spit out an executable. You can run the executable. I guess this might be confusing, but so the print function comes from this basic module.
Yeah.
In Jai, the order you define things doesn't matter, so you can put your imports above or below, and it works just the same. Seems like more and more people prefer to put it below, put their imports like at the bottom of their files instead of at the top, but I think it's just a matter of taste. So yeah, that's kind of a brief introduction to the language, and the first big feature I wanted to talk about is compile time programming. So in Jai, you can do arbitrary compile time execution, which means you can run any code you want at compile time, same as if it were runtime. And when they say any code, they do mean any code. And so for me, what I like about this is that coming from C and C++, in C, if you want to do something at compile time, a lot of times it's messing around with preprocessor macros and hacking them together in weird ways that do something at compile time. It works, but it's painful sometimes. And then in C++, you have a lot of things you can do at compile time, but a lot of it feels very different than the code you would write to run at runtime. And it almost gets to the point where it feels like you're learning an entirely new language. Sometimes it really is an entirely new language. And so one of the things I like about the Jai approach is that everything that you know how to do in the language, you can just keep doing just at compile time instead of runtime. And of course, this also means that you can reuse more of your code. So here's a little comparison between how you might do something at compile time in C++ versus how you might do it in Jai. So these are basic variables. We have a number, we have an array of numbers, we have a string view. If you wanted, say, a vector instead of an array, I think you can do that in C++ 20, but I had some trouble the last time I tried, so I'm not exactly sure. And then again, I think you can do a std string as a context for variable in C++ 20. But if you're pre-C++ 20, then you need to use a string view instead of a string. In Jai, it looks mostly the same. You have a number, you have an array, you have a string. For the way Jai does strings is a little different than C++. I'm not going to get into it here, but a compile time string is roughly the same as a string view in C++. You could make this a dynamically sized array, but this is a this is a fixed size array here. But you could do a dynamically sized array if you wanted to. So now let's say we want to make a function, let's say a table of sign values that we're going to use later in our program. So in C++, again, assuming we're pre-C++ 20, we would need our table to be a fixed size array, which means that the size of the array needs to be given as a template argument. And then when we actually want to compute the sign, we can't use std sign because it's not context for. And I think there was some talk about this getting fixed in C++23, but I haven't heard if that happened or not. But in the meantime, there are some third-party libraries you could use instead, like this GCEM library. It works. It's slow. I don't know. I don't love it, but it does the job. And then when you actually call this function, you can basically call it like a normal template function and then assign the result to a context-free variable, and that works fine. Now, the problem with this is that if you wanted to use this function at runtime, you probably wouldn't want to do it this way. You might want the size to be a option you could choose at runtime instead of a template argument. You probably wouldn't want to use GCM because your table will take like a minute to generate. So yeah, you'd probably want two versions of this function, one that you could use at runtime and one that you would use at compile time. Here's the Jive version. So we have a function that's going to return a dynamically sized array. We're just using the kind of regular argument mechanism for this n, which is the size of the table. If we wanted to, we could enforce that n is known at compile time, and then we could use a fixed size array, but we don't have to. So we'll just make our array, we'll resize the array, and then when we do our sign computation, we can just use the regular standard library math sign function. Then when we want to call the function, we're going to put it inside this hash run directive. So hash run tells the compiler, run this at compile time, and anything you put in this block here will be run at compile time. And in this case, we're able to assign the results to this variable sign table, which will be a compile time constant. Any questions about that?
Should I support recursive compile time functions?
I think so, but there's a limit. Yeah, if you end up in an infinite loop, at some point it's going to crash and give you problems. But I believe it does allow you to do that. But yeah, again, the nice thing about this is that you can write this function in such a way that you would use the same function at either compile time or runtime, which is pretty nice. So now maybe we want a template function. So in C++, we would have some template type T. And we'll say we want X to be of type T and Y to be of type T. And then our return value will also be type T. In Jai, this is what they would call a polymorphic function. So this $T is a polymorphic type. And Y also needs to be of that type. And the return value also needs to be that same type. I don't know. This part is basically the same between both languages. But then let's say you want to restrict what the type T can be. So if you're in C++ 17 or before, you need to do this std enable if thing. So we're saying, okay, let's check if T is a float. If it is, then enable this function with return type T. At least that's how I interpret it. I've heard different explanations, enable if, so I'm sure there's more to it than just that. If you've used enable if, you know it's not the most fun thing ever, but it does work. But if you're in C++ 20 or later, then we have concepts. Personally, I think this works a bit better. Unfortunately, I can't use C++ 20 for most of my code, but yeah, you can just do requires and then whatever compile time Boolean thing you want to check. So that's a lot better. In Jai, they have this block that they call a hash modify block. And so the idea with hash modify is that when this function gets compiled, the code in this block is going to be run. So you can put any code you want here. You can read from a file, you can open up a web browser, you can do whatever you want. But then at the end, if you want to, you can return a true or false value that will tell the compiler whether this function should be allowed to compile or not. And then you can return an error message if the compilation fails. And so this is nice. Even with concepts, sometimes the error messages get a bit unwieldy. So it's nice to be able to just define your own and express it in whatever way it makes sense that you'll be able to read it back later and know what you meant. Oh, and it's also possible to do hash modify for structs. It works basically the same. So now you might be thinking, if we can use this hash run to run arbitrary code at compile time, and maybe we need some custom build logic for the compilation of our program to work the way we want it to, well, why don't we do something like this? Let's put our custom build logic in this function called build, and then we'll do hash run build so that function is called at compile time. And that's basically our build system. So This is what they usually call, the Jive people usually call a metaprogram, which is a Jive program that instructs the rest of the program how it should be built, basically. And so again, the nice thing about this is that you don't need to learn a whole new language or software just to build your program. I'm sure most of us here have fought with Make or CMake or Visual Studio or one of these things. And I don't know, personally, when I think about all the time I've spent learning CMake, and again, I'm certainly not an expert in CMake, but if I took that time and had put it into C++, probably be a lot better C++ programmer by now. Just a thought. And of course, it's nice too that any code that you would maybe use in your regular program, you can also use in your build system. So for me, in a lot of my build processes, I need to rename files and copy files around on disk. I already have code that does that, so I can just use it at compile time, and it's great. Maybe you need to do some text manipulation, like something that's pretty common if you need to interoperate with C. Maybe you want to generate a C header for some structs in your Jai code. You can do that and just write it to a file whenever you build. So there's a lot of things like that that are very nice. You can run your tests at compile time if you want. And the language also gives you some nice interfaces for interacting with the compiler. So one of the things I noticed about Jai is that when you run Jai-help on your command line, there's only like 9 or 10 options. Whereas if you've ever run like Clang --help, you probably have to wait a while for it to finish scrolling. And so part of the reason for that is that most of your build options are things that you can just set as part of your metaprogram. So here what we're going to do is we're going to say, I want my output executable to be named this. I want it to be a static library. I want to set, these optimization flags, whatever that means. Maybe you're building for iOS, so you want to use this target triple for LLVM. And the nice thing about this is that it's all documented the same way like a normal code API is documented. So like this output type is an enum. You want to know what your options are, you just go look at the enum and you see, oh, executable, static library, dynamic library. I think there's another one. But yeah, that's, at least for me, I found that preferable to reading through Clang's list of options. Yeah.
So if there's no build system, what pays attention to the target options when you set them?
So what we're doing here is we're asking the compiler for the workspace that it's going to use to compile our program. And then we're setting the build options for that workspace.
Got it.
Actually, we're not, because I didn't call set target options or set build options at the bottom. So
Yeah, you did. You called set build options DC right there, right?
yeah, I think there's something else I need to call though that I forgot. So maybe it doesn't work exactly, but yeah, that's the basic idea though, is you'll tell the workspace, hey, compile this code with these options. And if you want, you could create multiple workspaces and compile multiple versions, or make a debug build and a release build at the same time or something like that. There's a few different ways that you can interact with it.
Is the name build for the function special like main is, or is it just conventional?
I think it's convention, but yeah, basically you could name it anything and then you would just have to put that name there so that it knows to run at compile time. Any other questions? Cool. So then the other thing you can do is intercept compiler messages. So the way the compiler works is that it's kind of a message loop in a sense. And if you want, you can insert yourself into that message loop and receive messages that come back from the compiler. So what we're doing here is we're saying, hey, let's intercept the compiler message loop for this workspace. And then we'll run an infinite loop. And every time the compiler gives us a message, we can do something with it. Here, all we're doing is wait till we get the complete message, and then we'll exit the loop because the compilation's done. But there's a lot of interesting things we can do with those messages. Yep.
Oh, I might be jumping ahead.
Sure.
Can you intercept other things besides messages, like the AST?
Well, those are
token
part of the
string?
messages. So the messages.
Oh, okay.
give
So
you
the
there's a lot of
So
information.
you've really actually got the compiler's
Yes.
string. Okay, so it's not just a message, it's the whole stream. Okay.
Yeah, so they call it
That's
messages,
interesting.
but there's a message that says, oh, I just finished compiling a function, and you can ask it, well, what function? And then, what's the name of it? What's the return types? What's the body of the function? And things like that. Or I just finished type checking this function, things like that. So yeah, there's a lot of things you can do with compiler messages. You can log them, that's obvious. You can inject code and modify code in place. You can walk through the AST, you can modify it or just inspect it, whatever you want to do. You can do these things they call compile time sanitizers. So something that I've noticed a lot these days, people seem to care about safety and freshness and things like that. Personally, I'm not a huge fan, but maybe I should be. But yeah, I know a lot of languages, like for example, with Rust, they seem very strict about this is how we enforce safety and how we enforce correctness and things like that. And it's kind of tricky because for me, there's things that I know I need to do to make my program safe, but they're not really on the Rust compiler's radar, so I can't really enforce them. Well, the nice thing with Jai is that you can choose what rules you want to enforce and just write a metaprogram to enforce it, or use someone else's metaprogram for it. So something I know that was talked about early on was writing a sanitizer for the MISRA guidelines. So if you have some industry-specific rules about how your program needs to work, you can write a sanitizer that confirms that and that enforces that at compile time. Maybe there's some other best practices that your industry or your program architecture need to have in place. You can enforce those. Maybe just have house rules of how you like to do things. And then once you've kind of got some useful metaprogram that does something, you can package up part of it as what they call a metaprogram plugin and then share it with other people. And it makes it easier to not have to roll your own version of this every time you want to build a program. You can just write it once and then link to that metaprogram plugin, and it works pretty nicely. That said, all of this stuff you want to do at compile time is great, but it does make your compile time slower. So if you do too much work at compile time, it will slow down your compilation. So maybe you only want to run your sanitizers every now and then, maybe not every build. Kind of up to you how you want to do that. Cool. So I was going to move on to this other thing called the context, but if people have questions about compile time programming in Jai, I'm happy to talk about that more. Okay, we'll come back to a little more at the end too. So the idea with the context, I guess it requires a bit of explanation. So when you're writing code, or when I'm writing code, I kind of have a distinction between writing application code and writing library code. And the idea with library code is that it should be reusable and maybe other people can use it, not just me. And when you're writing this kind of library code, you want it to be, sometimes you want it to be as general as possible so that a lot of different people can use it. But when you're writing this general use code, you have some things that maybe it's unclear who's responsible for what. And some of these things might be memory allocation or logging or error handling, things like that. And so, you know, let's say I'm writing my application code and I've decided that I need to use some custom memory allocators because, I don't know, I'm doing something that needs that. And so whenever I use an STD vector, I provide my own allocator as a template argument, and that works fine. But now I go to use some third-party library, and the library code doesn't expose that allocator as a template argument or something. So if they're using STD vector somewhere internally, I can't use my custom allocator with it anymore. That's annoying. I put all this effort into using my custom allocator. So, okay, maybe I don't use that library, or maybe I rewrite it or modify it or something like that. And then maybe I want to override cout or something like that so I can do my own logging or, you know, whatever I want to do. But I want to use some third-party library, and that library uses printf or some other way of logging. And, you know, maybe I figure out how to intercept that, or again, rewrite it or modify it in some way. And then, of course, lots of libraries have their own way of doing error handling. People use exceptions, people use error codes. A lot of times those error codes are not the same as what other libraries are using. So that can be confusing. And then there's things like optional and expected that also are ways of expressing types of failure in your program. And so the bottom line is that if you care about any of these things, it can be difficult to use third-party libraries because either those libraries have to think the same way you do, or you have to have some kind of abstraction layer between the library and your program so that you can, let's say, translate their error codes into your exceptions or vice versa. So this can be kind of a challenging thing in C++ and in some other languages as well. This is where the context comes in. So this is I just copied this from the I guess, standard library, you'd call it. And this is what they call the context base. So you've got a thread index, you've got an allocator, you've got some logger stuff. There's this thing called temporary storage that we'll come back to. There's some stack trace information. There is a way to compile it with no stack trace information if you don't want that. And then there's stuff for handling assertions down here. And so the idea is that every procedure or function in your Jive program is passed a pointer to a context implicitly. So you don't have to have it as one of your arguments. It'll just be there as if it were an argument. And the context is basically a struct that is derived from context base, but it also has, there's a way for users to add their own things to the context. So it's got maybe some extra stuff. And there's some things in the context that are per thread. So obviously the thread index is going to be different between contexts on the different threads. Now, if you don't want the context to be passed implicitly, like for example, if you need to interoperate with C, then you can mark your function as a C call, and it won't be passed a context implicitly, but you can still do it explicitly if you want. Skip to the slide. Okay. And so the idea with the context is that in my app code, I can just say, okay, let's make the context allocator my custom allocator and the context logger, my logger, whatever. And then I can call some third-party code. And I don't really have to worry about what that third-party code does internally because, for example, let's say it resizes a dynamically sized array. That's not going to call malloc. That's going to call context.allocator. And so it's going to call whatever allocator I've chosen to assign as the context allocator down here. So basically, I can choose to override the global allocator, and sometimes even in a very granular way, just as part of my program. And a similar kind of thing with logging here. So if the third-party code wants to log some information, it can do that through the context logger, and I can choose as the application kind of top-level programmer, I can choose what that does. And then kind of a next level after that is this thing called temporary storage. So temporary storage is a linear allocator. It's similar to what some people refer to as an arena allocator, but I've heard the term arena allocator also used in other ways. So I think linear allocator is maybe the most descriptive. So each thread gets its own temporary storage. And one of the nice things about that is that you can do your allocations very fast because you never need to synchronize with any other threads. And the linear allocator is a very fast type of allocator. You also don't deallocate any of your individual allocations. So if you say, I'm going to allocate, 100 bytes in my temporary storage, I never have to explicitly free those 100 bytes. Instead, what I'll do is at some point, I'll call reset temporary storage, and that's just going to reset the entire allocator back to whatever the beginning of that memory is. There's also kind of just for convenience, this thing called temp, which is just a regular memory allocator that forwards to the context temporary storage.
Question on reset temporary storage. That basically just deallocates everything, right? Is that?
Well,
it's sounding like a big hammer, and I'm not sure if that's right or.
So the way to think about it is that temporary storage is like a big array of bytes, and then every time you allocate, you're just moving a counter through that array. So when you call reset temporary storage, it just zeroes the counter.
Yeah, okay, so it really is deallocating everything.
Yep.
Okay.
Exactly. So this is how you might use it. You might say, oh, I'm going to set my context allocator to temp, and then I'll, call whatever I want to call, and that might allocate memory somewhere. And then when I'm done and I'm sure I don't need any of that memory anymore, I can call reset temporary storage, and that'll essentially free any memory that was allocated since the last time I called it. And then another kind of convenience thing built on that is this thing called tprint. So if you've ever tried to return a string from a function, let's say in C, it can be a bit challenging. Either you need to have a limit at compile time for the length of that string, or you need to malloc that string, and then you need to free it sometime later, but who knows when. And then if you need to do any kind of manipulation with string formatting or things like that, then a lot of times you end up mallocing many times, and maybe it slows down your program. Hopefully not too bad, but yeah, it can definitely be annoying. And so tprint is basically a version of sprintf that uses temporary storage for whatever intermediate allocations or things it would do. And so the nice thing is that you can return anything that's been created with tprint and not really worry about the lifetime, so long as you have basically an upper bound on the lifetime. So once you get to a point in your program that you know you won't need it anymore, anything else that was allocated into temporary storage, then you just call a reset and it deallocates everything. So for me, this is really nice. And I'll come back to it a little bit later, but I think in a lot of programs, there's kind of loops and things where you say, okay, I need a bunch of memory. I don't really care about freeing it, but then at some point I know I'm not going to need it anymore. Like, for example, if you're a graphics programmer, you render a frame. Once you're done rendering the frame, there's probably a bunch of stuff that you don't care about anymore. Just free it all at once and then use that memory again the next time through. So it's a nice pattern that I've started using a lot in C and C++ as well. But yeah, so that's the basic idea of the context. I'm going to talk a little bit more about how I use the context in audio programming. So I talked about this the last time I gave a talk here. I think it was last summer. So some of it might be familiar, and I'll go through it a little more quickly this time. But when you're doing real-time audio programming, you have what they consider kind of a hard deadline where you need to finish your computation by a certain time. And if you don't, then you get a click or a pop or some kind of glitchy sound that usually you don't want. And if, let's say if U2 is using your software in front of millions of fans, you really don't want that click, yeah, or something. It could, really hurt people's ears, or if not, just sound really bad. So you really don't want to miss your deadline. And so if you're thinking about using a pretty standard memory allocation mechanism like malloc or new or something like that, you shouldn't do it as part of your real-time code, because it doesn't have a deterministic execution time. And so they say it's not real-time safe is usually the phrase that is used. And so if you want to use third-party libraries, that's problematic. So a couple months ago, I was working on this reverb plugin that a friend of mine was working on. They were using the eigen library, which you know very well. And kind of sneakily, maybe 30 layers down in the eigen code base, they call malloc in a few spots. And so, yeah, so like they had this great sounding reverb, and then every few minutes it would like crackle or like make a little glitchy sound, and they couldn't figure out what it was. And so eventually I was looking through it, and it was like, oh, I didn't know that eigen allocated memory sometimes, and every once in a while it would cause a glitch. And so that was kind of problematic, and turned out to be, we were able to solve it and still use eigen, but it turned out to be complicated. I can talk about that more later if people are curious. But anyway, so here's how I would write my audio code in Jai. So basically, let's say I have a struct, that's my audio processor. I'll have a bunch of, I call storage data, so it's just an array of chars basically. And then I'll have a temporary storage that I can use for the audio thread. And basically, I want to pre-allocate some backing data that I can use for my temporary storage. And I want to make sure that I pre-allocate enough that I never run out, is basically the idea. And so I'll have some init function I can call, and I can call this function and say, this is how many bytes I'm going to need. I should never need more bytes than this, hopefully. And then all I have to do is resize the initial data that I'm using for my temporary storage. And then I would call this function to basically tell temporary storage, use this data instead of allocating your own. It's not super important, but it just tells temporary storage to work in a certain way that's different from how it would work normally.
It looked like, so temporary storage looks like a type there. It's like a separate type from, in your struct.
Yeah, so oh, did I write that incorrectly? Okay, so that's the name and that's the type.
Yeah, so temporary storage is a type, a different separate type from just any other bytes.
Correct, yeah, it's just a struct that basically it has a pointer to your bytes and a counter, and I think there's a couple other bookkeeping things.
It doesn't need to know what it's holding, it's just some bytes.
Yeah, exactly. I'm skipping slides. Okay. And then in my real-time code, basically what I would do is create a context, set the context temporary storage to my temporary storage, and then set the allocator to temp, which will point to the temporary storage. And then there's a couple of kind of JAI keywords here. So the first is push context. Basically that says, until the end of this scope, use this context as the global context, really global, but just for this thread. And so anything I do in here will use my allocator, which is backed by my temporary storage, which is already pre-allocated, so I don't have to worry about malloc or something like that being called under the hood. And then defer basically just means run this at the end of scope. And so when I get to the end of scope here, the temporary storage will get reset and I can use it again the next time. And then after that, I can just do whatever work I want and allocate memory as much as I want. And well, okay, not as much as I want, but as much as I want up to however much I've reserved for myself. And I don't really have to worry about anything being real-time safe. I can use third-party libraries and whatever. And yeah, it all works pretty nicely. And is I can be much more fearless in the things that I do, which is nice.
So does that mean you can use defer to get the benefits of RAII?
Yep, yeah, you can do that. Yeah, that's kind of a, well, I don't know if it's a common pattern, but it's nice to be able to say, allocate something and then free it at the end of scope, or set a variable and then reset it at the end of scope, things like that. So you can put those two lines right next to each other, which is great. There's sometimes where it can get tricky to figure out which order your defers are going to be called in at the bottom, because it's like kind of reverse order. So you have to like backtrack up through. But yeah, if you only have one or two of those per scope, then it's very easy and it's quite nice. Good. So you might be asking, yes.
Can I ask a question about so what happens when you actually run out of that temporary storage memory? Is there some sort of indicator, or your program just crashes?
Yeah, so there's kind of choices that you can do. So the default temporary storage behavior is that when it runs out, it will allocate a new kind of chunk of temporary storage, and then you'll basically have multiple chunks to work through. You can tell it not to do that, and if that's what you choose to do, then you will crash when you run out. Or I think it'll just return null, and if you don't check that it's null, you'll crash.
Okay.
So yeah, there's some choices there, but the default is to just keep adding new chunks. I usually don't do that in my audio code because I want to know when I mess up and I want to crash. So that's the route that I take, but it probably depends on what you want to do.
Okay.
Awesome, thank you. Cool, yeah, so you can just do this in C++, and I do it all the time and it's great. However, it's a lot less convenient. There's a lot more kind of manual work that you need to do to make it happen. And of course, one of the problems is that you can't reuse as much code. So kind of like with what I was talking about before, where you might have a compile time version of a function and a runtime version of a function. Kind of the same thing where I'll have like a audio version of the function and then a non-audio version of the function. And yeah, it's not ideal, but it does work. And then of course, if you want to use a third-party library, you probably can't use your own temporary storage construct with the third-party library because it doesn't know about it. So that's kind of a downside, but you can use this pattern in C++, and I actually highly recommend it. It's very nice. But then you might ask, well, how can you be 100% sure that you're not allocating memory on the audio thread? So for example, what if someone bypasses the context allocator and just calls the alloc function directly, which is basically their version of malloc? So that could be a problem. And then what if a third-party library resets the context allocator and uses to do something else? So this is where the idea of a real-time sanitizer becomes very useful. So kind of like address sanitizer, thread sanitizer, you can use a sanitizer to check that you're not breaking any of your rules for what you're allowed to do on your real-time thread or in your real-time code. Now, if you're very up to date with what's happening in the LLVM project, there's a fairly new advancement called real-time sanitizer, which has been added to LLVM. It's developed by these guys, David and Chris, who are audio developers, plus a few more people who aren't audio developers. I don't know them And in LLVM version 20, they're supposed to be releasing real-time sanitizer. I think that's going to be early 2025, but we'll see when that actually happens. If you want to know more about how this works, David gave a great talk at the Audio Developer Conference last year, and then David and Chris together gave a talk at CPPCon a month ago. There's no video available, but whenever the CPPCon videos come out, you should be able to watch that too. Now, the past couple weeks, I've been working with them to try to add Windows support to real-time sanitizer, and turns out it's really hard. Not just adding Windows support, but any of this in general is really hard. LLVM is a very complicated project, and working with it is very complicated. And doing all the stuff that you might want to do to get a real-time sanitizer to work is very complicated. But let's see if we can do it in Jai. And so for Jai, I ended up going with a different approach than the way that the LLVM real-time sanitizer works. So for my Jai version, I decided to use a compile time sanitizer instead of a real-time sanitizer. So it's going to check my code at compile time instead of as it's running. That said, I think it would be roughly, I think it would be very similar to do a runtime sanitizer. I don't think it would be that much different. And so this is basically how it works. So I have a function that I'm going to call as part of my real-time code. I'm going to mark it with this noalloc decorator. And so basically any function here, you can just put add something after it, and that will just be a note that's kind of appended to it. So when the compiler compiles it and it generates a message, hey, I just compiled this function, and you're in your metaprogram and maybe you're asking for information about the functions being compiled, you can see, oh, this function was compiled with the noalloc note. But then in this function, we're going to call bad function, and in bad function, we're going to call alloc, which is not real-time safe. And so when we try to compile this code, we'll get a compilation error that tells us that we broke the rules of our noalloc decorator, and it tells us where that is. Still working on getting more of like a full stack trace to print, but it does tell you at least where the lowest level of the stack is. So that's kind of nice. And this took about 3 hours to do in Jai. I don't know, I was kind of hungry, so probably could have been faster if I was well fed. And it's about 100 lines of code. I think if I was better at Jai, I could probably do it in like 50 or 60. It's not terribly complicated. It can't quite do as many things as the LLVM implementation. And mainly that's just like how many functions it's looking for. Like alloc is not the only function that wouldn't be real-time safe. So really, I would probably want to check for a bunch more. But the logic for doing that is roughly the same. I think it's pretty good for my first shot at it. And I do have the code here that we can look at if you guys are interested. We have some time. Okay. Yeah. So
If we're good till 8.
sweet.
I have a question.
Yeah.
If you call a library, will that noalloc allocator also apply to the library call?
You call a library. If it's a Jai library, yes. If it's like a statically linked library, probably not. Yeah, I don't think it could tell through like that boundary. Yeah, I guess that is a nice advantage of the LLVM approach, is that they're kind of doing that interception at the C runtime library level, I guess. So I think it can operate through that boundary. So yeah, that is a nice benefit of their approach. So yeah, this is the code. I don't know if I can make it bigger. This editor is also written in Jai. It's also still in beta.
If you're presenting a window, you can sometimes shrink the window and that'll have the effect of magnifying.
Oh, that's true, yeah.
How does this work?
I've got the whole screen. Oh, it just
Oh,
gets
no, that didn't help because the text got smaller.
Well, let me see if I can do font. About Control plus. No.
It looked like when you were resizing the
Yeah.
window, the text was changed. Maybe if you just drag the window to put, instead of full screening. Yeah. Oh,
Is that okay? Not for me.
it was.
Point. Yeah.
And then it.
That's as far as it goes. Okay, I can use a regular text editor too, if that's. Let's just do good old VS Code. Okay, that's big, right?
Yeah.
Cool. Okay. Yeah, so this is the same code that I was just showing you. Let's see if I can confirm that it works. To go to the right directory. Yeah, there we go. Okay, cool. So this is the actual metaprogram here. So first thing I'm doing is just like normal build options. And then here's kind of the message loop. So of course I have my completion check. And then there's kind of two things I'm looking for here. So one is this type checked message. So as each method is type checked, I'm adding it to this array. So I have all the procedures here. And this is like the type for a code. Yeah, the body of a code procedure. And so I'm just adding all of those to this big array. And then here, this is kind of the compiler letting me know that's moving to a different phase of compilation. So here I'm seeing, oh, we've reached this phase of we've type checked everything that we can. So now I'm going to go ahead and check that all of my procedure bodies are correct in the sense. And so first thing I do is I check if the procedure is marked with this no alloc decorator. And that's pretty easy. All I do is loop through the notes field and check if the text is no alloc, because that's the name I gave it. If it is, then it's true. If not, then it's false. Where'd it go? Here we go. And then if it's marked no alloc, then I know I need to check it. And so all I'm doing here is going through the statements in the code and checking that those expressions don't allocate memory. And then for those expressions, if it's a function call, then I just check directly. Oh, sorry. If it's a call to a procedure header, then I check that that procedure header is not alloc. And if not, then I just forward to kind of the next expression that's part of that thing. So like, for example, if it's a kind of an identifier, then I check that the, I guess what they call the resolve declaration expression is also not a procedure header that is alloc. If it's like a binary operator, like a x plus y, then I check that both sides of the operator follow the right rules. And then similar, like all these things are like sub-expressions of larger expressions. I think there's probably a way to kind of collapse a lot of this logic, but I haven't figured it out yet. So yeah, this function probably can like mostly go away once you figure out how to make it go away, but I don't know yet. Yeah, any questions or things you guys want me to try?
So the no alloc decorator, is that something that you defined yourself or is that part of the language?
Yeah, that's what I defined myself. So
okay, so you can make your own custom decorators that don't have to be built in.
yeah, and you can just mark it like, something, right? And that'll compile fine. And the only thing that will do is that now when I look through my notes, there's just a new thing in there. So yeah, you can just mark things however you want, and they can either have meaning or not, depending on if you do anything with them.
Seems pretty powerful.
Yeah, there's a lot you can do. I've only gone through my favorite features.
So your alloc check, you built this into your build script. How would you kind of structure it if you wanted to make it sort of reusable, so like I could use it in my build function?
Yeah, so I'd have to look at kind of the API for the metaprogram plugins. I've never actually made one.
So there's a few steps.
Exactly, but then on the usage side, if I already had it done, I could just use this dash plug and then the name of my metaprogram, and your program would compile with that metaprogram too. So on the user side, it's very easy. I haven't really looked at what it looks like on the
How to make it, but
yeah,
to consume it looks nice.
Yeah. And then probably what I would do if I were trying to go for a real-time sanitizer is I would, actually this might be easier now that I think about it, is I would go through here and I would check if the procedure that we're type checking is the actual alloc function, and then I would just add some code to the body that says, that checks if we're on the real-time thread and does something with that. Yeah, I probably should have done that. That would have been easier.
Yeah, I was gonna say, like, you can correct me if I'm wrong, but it seems like you're texturally looking for the alloc function itself.
Yes, yeah.
Okay, so it'd be interesting. You could extend that to other functions too.
Yeah.
Yeah, basically I would just, where to go? Yeah, instead of this, I would just say like,
How does
bad functions,
Yeah.
Mhm.
alloc, I don't know, fopen, probably some other ones. And then I would just check all of those instead of just alloc. Yeah.
I was gonna say, this compiler evaluation looks a lot cleaner than Rust on its procedural macros.
Yeah. How does that? I've heard of some people trying to do this kind of thing in Rust.
Yeah, it's
Seen too much.
conceptually similar.
But it's got like it's another language
But
problem.
yeah, well, it's not another language, but it's a whole nother library, right?
Yeah.
You're getting a whole, and I've gotten into it a little bit, just enough to know what it is and when I need to use it.
Mhm.
And I haven't gotten the needing to use it yet. But it's basically a library where you're passed an abstract syntax tree,
Mhm.
you return an abstract syntax tree, and there's a bunch of libraries for manipulating and altering that tree.
Mhm.
And it's there. It struck me as a little involved.
Yeah.
But at the same time, I'm not a compiler person, right? So the thing I noticed or the thing I remember is it's all written in terms of like a compiler writer would think of
Yes.
things, right?
Yeah.
And I don't think that way. So maybe it's, more natural to somebody who's, involved with compiler.
Yeah, I will say that was a bit of a problem for me as well. So this is the actual like compiler module that ships with the compiler. And here, let's see, code. Yeah, here we go. So this is like the basis for all of the things that the compiler deals with. And yeah, I don't know, like, again, this is something like, I don't really know what some of these mean. I've never made a compiler before myself, but yeah, so there's a lot of things here that like, I'm not sure what I would do with, or if there's something I should be doing with them in my sanitizer. And that's also why I feel like there's probably an easier way to like walk through the things that are being called, but
Yeah,
I just haven't found it yet.
that was the same sense I got when I was doing the procedural macro stuff.
Mhm.
It's like, yeah, there's a lot here.
Yeah.
It may it may be a function too of, Rust is a much more developed language, so there's more to it
Sure,
to
yeah.
begin with, right? So,
I was gonna say, I don't know if we want to wait for the person to come back to ask this question about eigen. Presumably you're using boost eigen or,
The project I was working on was just using like eigen downloaded from GitLab or whatever, and then as like the header only version of it. I don't know that it's affiliated with Boost, but it might be.
is that like a C++ library or
Yeah.
Jai library?
Eigen.
yeah, Eigen's a C++ library.
Yeah. Oh, I'm not on internet.
Yeah, if you want, there's a password up there.
Wi-Fi code.
Oh yeah, good call.
It's the guest
MST,
one.
yeah, MST guest.
Okay.
Yeah, I just had two questions about that. One, were you like calling like the eigen code from within your Jai code? And then,
Oh, so that project was a C++ project.
okay.
Yeah. So that.
If you want to click event attendee code, by the way, and enter that code up there.
Oh, awesome. Okay. Sure. And it's the
MS event 472 BK.
2. Okay. Yeah, so that project was like another company that I've worked with before had this reverb effect that was already written in C++.
Mhm.
And then I was helping out with it. I believe it's possible to use eigen from Jai and other C++ libraries. It's a lot easier with C libraries to do interop. But I know some people have used C++ libraries. I think templates are thing, and I get used to a lot of templates, so that might be the tricky bit.
My curiosity there would be like, how would you like the testing framework for like, these audio libraries? Because you mentioned like there was popping. I don't know if the framework would be just simply listen to it multiple times, or you somehow extract the waveform, or.
Yeah, there's approaches people use. Definitely like, so the technical term for it is a buffer underrun, where you haven't filled up the whole audio buffer before your host system needs it. And so something that when I was working at Tesla, they would do is they would basically run the audio system for like 2 or 3 days and count how many underruns there are, things like that. Part of the problem is that the underrun is not always something that can be fixed. So sometimes you're doing something you're not supposed to be doing, and that's causing an underrun. But sometimes it's like, oh, the operating system descheduled your thread. Not much you can do about that, except for make sure you're running the highest priority thread. But if it's part of something running on a car computer, there's much more important things. Right. Have more priority.
With autopilot, yeah.
You want it to sound good still.
Yeah.
As you crash and go off the cliff, you make sure that base is still going.
The autopilot gets its own hardware, so we don't have to share resources with it. But,
That'd be.
That's good to hear, as I see them all driving around.
Yeah, but
Literally and
like,
figuratively.
even like
Yeah.
mapping and things like that, I think we're higher priority than audio. Audio doesn't usually get much
If there's some stair cycles.
Yeah.
I'll see if you-
Yeah, it's nice working with pedals and synthesizers, because the whole hardware is just for you and you don't have to share it with anyone. But yeah, if you're running on a computer, then you have to kind of beg the operating system. Remember.
So you did touch on one thing I was going to ask. So it does have a C or foreign function interface type of thing?
Yes, yeah, you can interop with C. And I've mostly the way I've used Jai in my real work is to compile a static library in Jai that I link to from my C++ program. And that's worked very nicely. Yeah, it's pretty easy to use a C library in Jai. Not so easy to use a C++ library in Jai, but also doable.
Yeah.
Depending on the situation. Yeah.
Generally the case.
Yeah. Well, just to kind of wrap up, should you switch to Jai right now? Should you go join the beta right after this talk? Well, probably not. So of course the language is in beta, and so the biggest problem I've run into if there's a product that I think, oh, I'd love to use Jai for this. Well, I might have to work with other people, or I might have to hand off the code to someone else at a later point. And if they can't access the compiler, then that's a pretty big problem. So that's probably the biggest reason not to use the language right now. It is an important one. So that's worth thinking about. Someone's asking me if I think Jai will become a widely used language. And honestly, I don't know. I think it definitely has a nice kind of niche within games, and maybe you would catch on with audio people. I'm one of only a handful of audio people I know that is using Jai, but I do think it has some really nice features that audio people would like. Outside of those two industries, I really don't know. I think there's some things that people in the embedded world would like, but also some things that people in the embedded world wouldn't like. So yeah, I don't know. And I think really it probably depends mostly on when the language actually gets released. So I think now we're at kind of an interesting time where like there's a lot of people using C++ and C who are interested in alternatives and are looking at Rust and Zig and kind of C++ extensions like CPP front and Carbon and things like that. And I think, maybe Jai gets released in like 2 or 3 years, and at that point everyone's found their alternative that they're happy with and they don't want to switch. Or maybe everyone's found their alternative that they think they're happy with, but turns out they're not actually happy, and then they all want to use Jai or something. So I think it really depends on kind of what happens to the ecosystem between now and when Jai does get released.
Or maybe C++ 29 sites.
Yeah, exactly. But yeah, in the meantime, I think a phrase I often hear in reference to C++ is that it's kind of a low-level language that gives you high-level features. And I think that Jai is kind of similar to C++ in that concept, but it takes a very different route to get there. So I think it's very useful to kind of see and appreciate that alternate route and think about maybe things that would be better to have in different ways. And also maybe what's not as good, what's better in C++. I'm not sure. I will say too that there's a lot of ideas from Jai that I've borrowed and I've used in C++, and for the most part they work great. But again, sometimes things with third-party libraries and stuff don't work out quite as nicely as you would want. And I think whenever I learn a new programming language, I think the most important thing for me is learning to think in kind of the mentality of that language. And I found that very useful, not just for programming, but also for solving problems in the rest of my life. And I think with Jai, there's kind of this mentality of like solving problems in a very straightforward way. Like I was showing my brother the slides where you override the context allocator, and he was kind of underwhelmed. He was like, "Oh, that seems too easy." I was like, "Yeah, it's supposed to be easy, and like sometimes just solving things the easy way is good. And if you can get to a point where you can do that, then it's nice." And yeah, hopefully that's kind of a mentality that I can approach problems with in programming and in other things as well. But yeah, that's all that I had. So thanks for listening, and feel free to email me or get in touch. However, yeah, thanks for listening.
That was an awesome talk. We're impressed with both the talk and the work you did in the
Thank you.
sanitizer.
I did want to spend more time on it, but last weekend I was like, all right, it's Sunday night. If I'm gonna do it, I actually wanted to do it as a live demo, but I don't think that would have gone so well.
Next time.
Next time. Yeah.
Next time, maybe you'll have an effect that'll make me sound like Jaco Pastorius.
Oh,
Nice.
yeah.
Now I'm scared.
Yeah.
Okay.
Anyone feel like they want to use Jai?
That's interesting.
The function annotations, I mean, they look kind of like the CUDA
Yeah.
annotation things. It's like, man, just kind of imagining how
Oh, that's interesting.
right? And like if you could have like the device code generation as like this meta function build step. I don't know. It's just interesting
That's
to think
definitely,
about.
yeah, it's definitely interesting.
You got a comment in the chat.
Oh. Oh, thank you.
Yeah, I was wondering, Jai, is it it's like
Yeah.
Jatin's
My
audio interface?
favorite thing about the name Jai is that no one seems to know where it comes from or what it stands for.
It's got AI in it though, so that's.
Well, yeah, I've heard, because the guy is Jonathan Bloss. I've heard that Jai is John's AI, but I don't know if that's confirmed or not.
Jonathan Blow wrote this language?
Yes, yeah.
That's crazy.
Yeah, and so apparently, I don't know what the status of this is right now, but at some point the idea was that he was going to make a video game completely using Jai and then release the code along with the compiler to kind of show how it can be used for a presumably pretty big project. Last I heard of that was like 2019, so I don't know if that's still the plan, or I don't know, maybe. Seems like his games have a tendency of ballooning in scope. So who knows?
Okay.
Should we go to
With that, yep, with that, we'll wrap up. Just a reminder that there is a continuing chat at Red Robin, should anyone like to attend. And other one, I'm still looking for speakers for next year, if anyone would like to speak. We do have a meeting next month in November, which I don't remember what the topic is, but stay tuned. We do not have a meeting in December, so happy holidays. Okay, with that, I will wrap up the video, and I'm gonna go figure out how we're gonna get the video, because it's now into the wrong meeting.
Right.
So like something you said gave me a good idea for a meeting talk that somebody could do. We talked about